Next type, third type of the governor we are going to see is your Proell governor. So how this Proell governor is different from your Porter governor is in its construction. Okay. So look at this diagram. It is almost similar to your Porter governor, but the difference is your centrifugal balls are mounted. They are not exactly mounted here, but they are mounted on extended links. Okay, and this link is freely swingable. It can move like this. It can take various possible positions. It can swing freely above F here. So that is a small difference between your Proel governor and Porter governor. Porter governor, your ball was here, like what governor. But now what I have done, I have removed the ball from there and I have added a freely swingable link here. This link can move from this place to this place. It can swing depending on the centrifugal force. It's very simple. Okay. So depending on the speed it will move. But for most of your problems that we are going to do in Proel governor, this will be assumed to be standing vertical, even though there is a change in RPM. Okay, if there is one problem which has some inclination here, that problem will be a little bit complicated. Okay, a lengthy one. It's not difficult actually. It is lengthy. Okay. So most problems you will have this arm to be. That is an assumption. It will not be vertical. The problems assume the arm to be vertical and we proceed. So now in this derivation we are going to assume that irrespective of your revolution, this is going to be vertical. Actually, in practice, it has to go out, right? When the speed increases, it will go out. Okay. The Proel governor has balls fixed at B and C to the extensions of the links DF and EG. So these two are the extension links, DF and CG. This is C. As shown in figure, the arms FP and GQ are pivoted at P and Q respectively. So don't worry about that. Consider the equilibrium of forces on one half of the governor. So here we are going to solve. The last case we solved by balancing of forces. So let us see how we derive this formula for a Proel governor. The instantaneous center is located here. You remember 4-bar chain mechanism. How did we locate the instantaneous center? Similarly, what I am going to do, I am going to extend this link. Okay. Similarly, I am going to extend as a horizontal line. They meet at the instantaneous center. I think this procedure you are very familiar from a 4-bar mechanism. I am going to locate that neither fixed nor permanent instantaneous center, which is somewhere here. And then using that, I am going to take moment. Okay. So I have located the instantaneous center here. Now I am going to take moment about the I center. Okay. So intersection of so that's what is told. Okay, instantaneous center intersection of the line PF produced and the line, that is what you extend this link, extend this horizontal line. They meet at the I center. That's what is explained in this paragraph. Okay. So taking moment about the I center using same notations as discussed in Porter governor. Okay, now let us take moment about this. So from here, the leftward pointing force Fc is at a distance of B to M, correct? B to M. So Fc into Bm equal to, what are all the rightward pointing force? W into Im. So it is taking in a direction of rotation. Okay. So if you see with respect to this, how does this rotate? It will go around in anti-clockwise direction, but this will go around in clockwise direction. That's why we are taking these things in the right side. Clear, like what you do in engineering mechanics. You just worry about the rotational direction. So this is my I center. So if I rotate this force about the I center, it will go around in anti-clockwise. But if I rotate this force around the I center, it will go around in clockwise direction. All the anti-clock in left side, all the clockwise in the right side, they will add up to equilibrium. Clear? Okay. So that's how I am taking moment now. So about the I center, Fc into Bm equal to, so this is the only force having anti-clockwise rotation, equal to W into, what is the distance of W from I? This perpendicular distance is this much. Okay, that is Im for this force. perpendicular distance. Okay, so W into IM plus this one. This will also go around in clockwise direction if you rotate about the I center. So W by 2 into ID. Clear? These are all the three forces. Only three forces are seen in the diagram, right? So FC, W, W by 2. All the two. These two will go around in clockwise. So they are kept on one side, and this will go around anti-clockwise. So it is kept on the other side. Clear? So now let's move on to the next step. So that is equal to, instead of W I am putting mg. So they are capital W I am putting capital M into G. So mg into, in place of Im I am writing, and so I am bringing this Bm to the right side denominator. So Im by Bm. Similarly, uh, so these two things what I am doing, mg into Im by Bm plus mg by 2 into Id is split up. Id is split up as Im plus md divided by Bm. Okay, we will see why later. Multiplying and dividing by Fm both sides. So left side will remain unchanged. Right side Fm by Bm. So what I am going to do is I am going to multiply and divide Fm into the brackets. Okay. So what will happen? In both the brackets you will have a Fm by Fm. One Fm divided by Fm will be here. So here also you will have one Fm by Fm. So what I am going to do is I am going to take this Fm by Bm as a common term outside. Okay. So if I take that as common term outside, what will be remaining here? Mg into Im by Fm. Correct? Im by Fm. Similarly in here, Im plus Md by Fm. Im by Fm plus Md by Fm. That's what. The same thing is split up into term. Im by Fm plus Md by Fm. That is Im plus Md by Fm. Clear? So since you have taken this as common term outside. Clear? So I can write from this diagram what is Im by Fm. Look at this. Im by, so for this triangle, Im by Fm is tan alpha. Similarly in this triangle, what is tan beta? Md by Fm. Okay. So this is tan alpha, this is tan beta. If you look into this triangle, similarly this is tan alpha. Clear? Any doubts? So I am representing them in terms of trigonometric functions of the inclinations. Okay, so I am writing as, so Im by Fm is tan alpha from that triangle. Similarly tan alpha tan beta. Now I can take tan alpha as a common term outside. So Fc equal to mg plus mg by 2 into 1 plus tan alpha by tan beta. Since I am taking tan alpha common outside, this will become 1 and this will become tan beta by tan alpha, which is nothing but q. Okay. We got few more minutes. I will complete now. So we know that Fc equal to m omega square r. Substitute on the left side m omega square r equal to, and tan alpha equal to r by h. So why tan alpha equal to r by h? Let's go back to the diagram. So tan, yes, is anybody telling something? Anyone wants to ask anything? So I'll just wind up. Give me a few minutes. So instead of tan alpha, I'm writing r by h. So if I go back to that diagram, I can see that it is the radius divided by height of the governor. And in place of tan beta by tan alpha, put q. So the formula will get simplified. M omega square r equal to Fm by Bm into r by h. So in place of that, so here you can put r by h. Here you can put q. So same thing is written again here. So m omega square r equal to, okay. So Fm by Bm into r by h into 1 plus q. I think we got some 2 or 3 more minutes. I will complete. Same thing, I am striking out the r on the left side. M omega square r. That r is cancelled with this numerator r. Bring everything except omega square to this side. And then what you do? 2 pi n by 60. Substitute everything and find the formula. You will get the formula as, okay. So this portion is very familiar to you. This is your Porter-Givernor formula. Okay. In front of that, you will have Fm by Bm for a Proell Givernor. It's almost similar. Just that Fm by Bm ratio is to be put in front of the Porter governor formula for getting the formula for a Proell governor. Okay, so that completes the derivation. N square is equal to Fm to Bm into M plus M by 2 into 1 plus Q divided by M into 895 by H. It's very simple to remember because you already know that. So there are some special cases. Equation 1 may be applied to any configuration, but you can go back in the video and see which is equation 1. Comparing equation 3, so it is proportional, okay, to the Proell governor formula. That's what he's trying to say. And alpha equal to beta, q equal to 1, therefore the equation 3 may be written as, it may be simplified. The same thing what you do in the previous case. M plus M by M into 895 H. Okay, so that completes the derivation. So it's taken from a Kumi textbook.